Hi there, this is Math 8, Unit 7, Lesson 9, describing large and small numbers using powers of 10. Alright, so we're going to find out how to use powers of 10 to write large or small numbers today. So first thing it wants you to do is to match the expression with a corresponding value and then its word. Okay, so let's take a look at some of these here. We have some negative ones and positive exponents here. So let's do this. Let's start with a positive one. Maybe it's a little easier to take a look at. So 10 to the third can be written as, remember you're looking at how many kind of zeros are after the 1 here, so it's going to be 1, 2, 3 zeros there. So 10 to the third becomes basically 1,000. So that's going to match this guy right here. This is our 10 to the third one, equals that one. And 1,000 is right there, and so we're good for 1,000 matching up like so. 10 to the 12th is going to be a lot of zeros, 12 zeros, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So as a number, that's going to be quite large. We're talking about a number there. Oh, we're going to say that's going to be thousands, millions, billions, and we're now in the trillion section here. So that's going to go up here with this guy. This is our 10 to the 12th power with our 12 zeros, and that's going to be our trillion. And you can just write it down there if you wanted to, or you could draw a line, whatever seems to work for you. Alright, now our other positive one, here we have 10 to the 6th power, which is going to line up right here. That's this one. That's easy enough, 10 to the 6th. And now we're in we have hundreds, thousands, millions, billions. So that's going to go to the billion one right there. Alright, and that's 10 to the 6th. Got it. 10 to the 9th. Oh, sorry, 10 to the 9th power. I'm so sorry. 10 to the 9th power. Wrote it down wrong. I was looking cross-eyed there. That's alright. And now 10 to the 6th goes here with 6 right there. So here's our 10 to the 6th power, and that's going to be in the million section. No problem. So now we've done the 6th, the 9th, the 12th, and the 3rd. And we're left with now those ones that look like fractions. Okay, so don't get nervous about them. Not a big deal. Think of it this way. Here's 10 to the negative 3. Okay, the negative sign negative 3 tells me that it's going to be in the denominator. But let's just pretend it's positive for 1 second. 10 to the third would be 1 with 3 zeros. Okay, and the negative third power tells me it's going to be in the denominator. So now we're talking about 1 over 1,000, which is right here. This is 10 to the negative third. And so as a fraction, as a word, that is 1/1000th, right? Or yeah, right, 1/1000th. No, sorry, we don't call it thousandth. We would call it there, in this case here, we're going to go with a milli, all right, because if you write this out, then you end up with 0.001. That's how you write that out. And so this is going to be the tenths, hundred, and the thousandths is the place value there, but the word is going to be a milli, kind of like a millimeter, that kind of thing. All right, so we're going to go with milli up here. No problem. Sure, we'll go with that. And then over here, our last one, 10 to the negative 2. That's 1 with 2 zeros, and it's a fraction, so 1 over 100 goes right here. 10 to the negative 2, and so 10 to the negative 2 is written as a decimal. If you wrote that out there. So 1/100th is 0.01, like that. And so that's going to go with the centi. Alright, it's 100. Alright, and that makes a little more sense. Okay, so we'll leave it like that for now. That's the idea there. In the next activity, it says, for each of the numbers, think of something in the world that is described by that number. Okay. So for the numbers, think of something that's described by that number. So what do you use to describe something that is a trillion? Now a trillion might be something like stars in the universe. Maybe there are a trillion stars out there. Okay. For a billion, you might talk about the number of people, you know, on a continent. That could work there. Right, and so you can think of things that work for these ones here in terms of size, right? Whatever you want to think about there. I'll let you do that with your classmates. Let's take a look at the next activity. To begin the next activity, we're going to do a little launch activity first of all here. All right, with our number cubes, like so. I just drew a little sketch of one real quick. Okay, so here we have a little sketch of some base 10 blocks. Maybe you're familiar with these, and perhaps when you were younger you knew this was going to be equal to 100, these were going to be our 10s, and this was our 1s. And it just shows that base 10 value, how you progress up and make things work there. Okay, so what if each square, and again this is 100 squares in here and 10 squares in each of these sticks, what if each square actually was equal to or represented one tree? How many trees would I have in this picture if this was one tree and these were all trees? So that's a tree, and so on and so forth. What would that represent? When you think about it here, if this is one tree there, and if you think about place values, okay, think about place values a little bit here, I have 3 spaces to fill in. So if that's one tree, great. Then over here I end up with 20 trees, right, which I'd write down as 2 and a 0, don't have to put the 0 there. In here I end up with 100 trees, so that's 1 and then 0, 0, right? So you end up with 121 trees. Not too bad. Now what if each one was 10 books? Okay, now again I have 3 places to fill in my 3 numbers here, but the first one now has a value of 10. See how that works there? Right? So if that's 10 books, then I'm starting at 10, which means that this is going to be then 200 because each one is 10. So 10, 20, 30, 40, 50, 60, so on, right? There's 200 there. So I have 200, which makes this one equal to 1,000. And again, the zeros don't really matter. What matters is that you're left with 1,210 because I made the first one equal to 10. Now what if I made the first block equal to 1,000,000? Same idea, right? Here's my 3 spaces I'm going to fill in, but now the first block is 1,000,000. So 1 and then 1, 2, 3, 1, 2, 3. It's 1,000,000. So if that's 1,000,000, that makes this one equal to 20 million. So 20 million, and that makes that equal to 100 million. So my answer here would be something like 121 million. Okay, it's a lot of stars, isn't it? Well, let's turn it into a decimal. What if the first one was 0.1 seconds? Okay, so that's 0.1, then this becomes a 0.1, which means that this is going to be equal to 2. Why? These are all tenths. So this is 1/10, 2/10, 3/10, 4, 5, 6, 7, 8, 9, 10 tenths, right? And what is 10 tenths? 10 tenths is equal to 1 plus another 10 tenths, which is another 1, which equals 2, which is where we are there. And this becomes 100 tenths, right? So you can think about 100 divided by 10. And what are you left with? You're left with 10, so 1 and 0. And so that's what you get, 12.1. Okay, let's try one more before I wrap this up. What if 1 square was equal to 10 to the third? Well, what is 10 to the third? 10 to the third is 1,000. That's what 10 to the third is. So again, my 3 space holders, my 3 values here, if that's going to be 10 to the third, then I start with here at being 1,000. And now I add the other numbers in, so I'm back to 121,000. Okay, so that's kind of our warm-up here to kind of get started with the activity that comes up next. Activity number 2 says match each expression to one or more diagrams that could represent it. For each match, explain what the value of a single small square would have to be. So we have the expressions here, and we're going to use the, let's see if I can get them on the screen here for you, the blocks down below. I'm going to zoom out a little bit. I don't like doing it too much, I know it's kind of small if you're watching this at school or at home, but hopefully you have your book here, you can take a look at what you have. Here I have 2 of those 100 blocks, and I have 4 there, right? So I end up with 2, I have no sticks, and I have 4 blocks there. Here I have 2, and I have 4, and I have no singles. And here I have no hundreds, but I have 2 and I have 4. Okay, so basically I'm looking at, if I was doing regular numbers like the old school style, I have 204, I have 240, and I have 24. Those are my three little sets there. Of course, that's not what this is going to be because we're moving around base 10s. Let's see what we have. A says I have 2 times 10 to the negative 1 plus 4 times 10 to the negative 2. Okay, so remember, a negative 10 to the negative 1 is what? It's 1/10. Okay, so I'm at 2 and 1/10. So I have like 2 times 1/10 is like 2/10. Plus here I have 10 of the, over that is 400ths. Okay, so I'm at 400ths, 2/10 and 400ths. So if I was to write that out, if I have tenths and I have hundredths, I have nothing over here. And so I could say that in our case here, I need a number that has a 2 and a 4 side by side, right? So which one has a 2 and a 4 side by side? The B does and C does, depending on how you want to look at it there. Okay, so I could actually go with B or C. If I said it was B and B worked out there, then this becomes, this is my 2/10, this is my 400ths, which makes a square equal to what comes after hundreds. A square would be equal to, in our case here, 1,000th, which is 1 over 1,000, right? And that should be 100 right here. I'm sorry about that. 1,000, which is equivalent to 10 to the negative third. Okay, that's what B would be. If I was going to go with C, we're looking here at, again, this is going to be 0.24. That means that, if this is 0.24, that the block, the last one here, which is the little block here, is going to be, if that's 0.24, it's just what it's going to be. It's going to be 100, because that's all we have. So that's going to be 10 to the negative 2. Okay. This next one, we have 2 to the negative, 2 times 10 to the negative 1, which is 2 to the 1 over 10. And here it's 1 over 1,000. Okay, so what do we see? We notice we're missing something in between, aren't we? We have a tenth and we have a thousandth and no hundredth space right here. That's a 2. So I have a 2 and a 4, a 0, and then a 4. So 204. So that's going to go ahead and match up with letter A best, because that one was a 204. So in this case here, this becomes written out as, since it's negative, 0.204. So in this picture here, what is the value of one little square? One square is here. This is 0.204. That's in this place value right there. So that's going to be equal to 1 over 10 to the, we have 10 hundred thousandths place. So 1 over 1,000, which is 10 to the negative 3. Okay, let's look at choice C. C, we have 2 times 10 to the third. 10 to the third is 1,000. 10 to the first is 10. We don't have any hundreds right there. So again, we're at 2, and this is a 0, and this is a 4, but this is 1,000. So I have 2, 1, 2, 3. So my final number is going to be 2,040. So which one do I have with a 204? That's going to be choice A again. But in this case, because I have 2,040. Why 2,040? This first value is 2 times 10 to the third. So that's 2,000 already. And I'm going to add to it 4 times 10, which is 40. So 2,000 plus 40 is 2,040. So what's the value of, if this is what I'm looking at here, what's the value of the 4 if I'm looking at 2,040? And this value here is going to mean that a square equals 10, or 10 to the first. The reason for that is that this is going to be 40 right there. This is 10, 20, 30, 40. And finally, D, we have 10 to the third, which is 1,000 again, and 10 squared, which is 100. right? And we're doing times 2, so we have 2,000 plus 400. So you're talking about a number that's 2,400 so far, is where we are. So where do you have 2 and 4 put together? Well, I have it with both C and with B. It makes a little more sense in the B one for now. So let's take a look at B. So if I used B, and so that was 2,400, so 2,400, 2,400. Okay, so that makes my, this is equal to 1,000, and this is equal to, right, this is my big blocks, this is my stick, and my little one is right there, which means my little square is going to be equal to 10, right? So a square in this case is equal to 10, or 10 to the first. If I use C, then I actually end up with, if I did C, I have 2 here, that's 2,400, like that, 2,400, and these are my sticks, right? And this is my rocks there, or my, I call them sticks and rocks, sorry, my second grade days. So that becomes my tens, and my 1 cube is there, which puts it into the hundreds place. So in the C value, the square has a value of 100, or 10 squared. Okay? So there's some different ways of representing some base 10 there. Alright? So hope it makes a little bit of sense. Let's turn the page and do some more practice. It just takes some practice to kind of play with it more than anything else. Zooming in and focusing. Coming into focus, maybe. There we go. It says, write an expression to describe the base 10 diagram if each small square represents 10 to the negative 4th. So if this right here is 10 to the negative 4th, because it's going to be negative, that means that this part right here is 10 to the negative 3, this part right here is 10 to the negative 2, and we don't have a space right here, but this base holder is 10 to the negative 1. Alright, so this is our 1/10, right? This is our, if we think about this here, this is point, well, I'll write this out for you, right here. This is point, and this right is 0, 0, and we have space, 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 right? This is our 10 to the negative 2, 10 to the negative 3, and 10 to the negative 4. I'm going to fill it in right there like that. So how many of these do we have? We have 2. How many of these? 1, 2, 3, 4, 5. And up here we have 4. Alright, so my number that's represented by this base 10 diagram, if this is 10 to the negative 4th, is 0.0254. And that's the idea right there, what that looks like. Okay. If I want to write that as an expression, I would write that as, this is 2 times 10 to the negative 2nd, right, plus 5 times 10 to the negative 3rd, plus 4 times 10 to the negative 4. That's my expression. So all of this actually goes with part A. Okay. B. How does changing the value of the small square change the value of the expression? So anytime we change this, it's going to either increase it by, it changes the place value, right? So it changes by a power of 10. And I'm going to go either up or I'm going to go down depending upon which way I change that there. So that's the idea, right? So if it was 1, let's pretend that the square equaled 1. So if that was equal to 1, then what I'd have is I'd have, in this case, starting right there, I'd have 4 times 10 to the 1st. Going backwards, I'd have 5 times 10 to the 2nd. Actually 10 to the 0 here, if that's equal to 1, and then 10 to the 1st, and then I have 2 times 10 to the 2nd. So I have 254. Okay, and that's to the 0 power, that way it ends up being equal to 1. Alright, select at least 2 different powers of 10 for the small square, and write the corresponding expressions. Okay, I'm going to just do one of these. Let's pretend this small square equals 10 to the third, or 1,000. So again, if it's equal to 1,000, I know I am working with three numbers, right? I have the 2, the 5, and the 4. And if the square, the first starting point, is my 1,000, then I'm going to have this be 4,000. That's my starting point. Because I had 4 of them, and they're equal to, in my case here, I just picked this, 1,000. So now I'll work back this way, and I have 5 of these and 2 of those. So that's what you do. You can pick one more. You can do that on your own. No problem. All right. We're in this next activity is something you do in class here with a partner. You have some partner statements, and you're going to be talking about the cards with one another, asking each other questions, and filling the missing information there with your partner. All right. Let's do one quick Are You Ready for More? And then we will move on to the homework for today. Okay. So, are you ready for more? If you square a Google, how many zeros will the answer have? So Google's a big number. It's a 1 followed by 100 zeros. So if we take a Google, which is a number, right, to the 100th power, and if we square that, when you're working with squaring a power to a power, then we multiply those things together, right? So that becomes n to the 200th power. So how many zeros will you have? You'll have 200 zeros. Now, if you raise a Google to the Google power, how many zeros will you have? So that's asking this, n to the 100 to the n to the 100 power. Now that's getting a little more complicated, right? So let's work with some numbers. What if this was 10 to the 100th times 10 to the 100th? Follow me? So if I had 10 to the 100th times to the 10 to the 100th power, then if I rewrote this, what this means is I'd multiply this part together right there. That becomes 10 to the 100 times 10th power to the 100. Oops, maybe 1,000. Sorry about that. Something like this. Right? Just rewriting that like that. Looks something like that. So let's turn this into a similar base. 100 is the same as 10 squared, and this is 10 to the 100 power. So we converted that 100 into 10 squared. Now I have two exponents of 10 that have the same base. When they have the same base, what do I do with these values? I add them. So I end up with 10 to the 10th power to the 102nd power. Right? 102nd power. Something like that. So, how many zeros would you end up having? Well, this tells you how many zeros you're going to have. You'd have 10 to the 102nd power zeros. That's how many zeros you'd end up with, which is a lot of zeros. Alright, let's take a look at your summary for today. It says sometimes powers of 10 are helpful for expressing quantities, especially very large or very small quantities. For example, the United States Mint has made over 5,000,000 pennies. In order to learn that number, understand it, we have to count all the zeros, right? 100,000, million, and then we get to billion. So we have 500 billion. That's exciting. Since there are 11 of them, this means there are 500 billion pennies. Using powers of 10, we can write this as 500 times 10 to the 9th. And they went 3, 6, 9, and that's how they got those separations. Or we can even write it as 5 times 10 to the 11th. We can add those other two and say it's 5 times 10 to the 11th. No problem. The advantage of using powers of 10 to write a large number is that they help us to see right away how large the number is by looking at the exponent. The same is true for small quantities. For example, a single atom of carbon weighs about that. Lots of zeros and 199 grams. We can write this using a power of 10 as 199 times 10 to the negative 25th power. Okay? Which means from this point here, I can go from here 1, 2, and I can keep counting all the way. And when I get here, I'm going to hit 25. Or if I wanted to, I could say it's 1.99 and put a decimal point right there, and now only go back 23 spaces. So not only do powers of 10 sorry, make it easier to write this number, but they also help avoid errors, since it'd be very easy to write an extra 0 or leave one out when writing out the decimal, because there's so many to keep track of and it'd be just hard to do it. So that's why the advantage of writing with exponents comes in. So go ahead and do your homework, and then let's correct it together. Okay, match each number to its name. Okay, all right, here we have a million, so that's going to be with 5. All right, this is million, got it. Here you have tenths, hundreds, so this is 1/100th, which is right there, number 1. Here we have 100, 1,000, million, billion, so that's choice 6, billion. All right, here we have tenths, hundreds, thousands, 10,000s, 100,000s, and then 1,000,000th, which is choice 3. Tenths, hundreds, thousandths, so 1,000ths, choice 2. And this is just simply number 10,000, which is choice 4. Number 2, write each expression as a multiple of a power of 10. Got it. So we're going to do it pretty simple. Let's just go ahead and just take the basic number here, which is 423. And how many zeros do we want to add? Times 10 to the 1, 2. And that works fine. If you wanted to clean it up a little bit, make it a little different, you could move the decimal over 2 spaces. If you want to move it over 2 spaces and make it 4.23, then this has to increase by 4 more, 10 to the 4th. Either one is fine. Here we have 2 times what? 1, 2, 3, 10 to the 3rd power. Here we can use 92 if we wanted to, and make it 10 to the 1, 2, 3, 4, 5, 5th power. If I want to move that over 1 space, which I could do, I could write it as 9.2 times 10 to the increase 6th power. 4,000 we know is written like this, so as a multiple of 10, this becomes 4 times 10 to the 1, 2, 3, 3rd power. 80 million. 80, 1, 2, 3, 1, 2, 3. That's what it looks like. So that can become, if we wanted to, 80 times 10 to the 6, or if I move it over 1, I could do it as 8.0 times 10 to the 7th. That works fine too. And then 32 billion, again, if I write out long ways, it looks like this. Billion, million, thousand, and hundreds. A lot of numbers. And that becomes 32 times 10 to the 3, 6, 9th power. Or if I move the decimal over 1, that could also be 3.2 times 10 to the 10th power. Alright. Each statement contains a quantity. We wrote each quantity using a power of 10. There are about 37 trillion cells in an average body. Okay, so trillion. So you have 37 and trillion. So trillion, after trillion is billion, million, thousand, hundreds, right? And all these are zeros that go in there. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So as a power of 10, this first one would be what? 37 times 10 to the 3, 6, 9, 12th power. Again, I could put that as 3.7 times 10 to the 13th if I wanted to, but we'll leave it like that. Okay, 300 billion stars. So again, 300, right? And we're going to go with billion. So that's billion, followed by millions, thousands, hundreds. So that's going to be 3 times 10 to the 3, 6, 9, 10, 11th power. Right, that's how to do it there. Okay, you can also do 300 to the 9th power, and that would be okay as well. A sharp knife is 23 millionths of a meter thick at its tip. Okay, so millionths. A little tricky if you're not thinking about place values here very much. So let's put a decimal here. This is our tenths, 100, 1,000, 10,000, 100,000, millionths. If something is 23 millionths, then I'm going to end my number at the millionth spot. 23 millionths, right there like that. That's my million. 23 millionths. Now fill in these zeros like so. So now as a value, I could say this is going to be 23 times 10 to the, and we have 1, 2, 3, 4, 5, 6 spaces behind the decimal, 10 to the negative 6th power. And that works just fine. If I wanted to make it 2.3 like that, okay, I could do that. But at 2.3, then I go 2.3, and that'd be times 10 to the negative 7. But leave it there. The wall of a certain cell of the human body is 4 nanometers thick. Nanometer is 1 billionth of a meter. So 1 billionth. Okay, so a billionth as a regular billion is 4, 1, 2, 3, 1, 2, 3, right? Billion, million, thousand, hundreds. So it's 9 zeros. Okay, so we do 4 times 10 to the negative 9 zeros. Now we're at 4 billionths of a meter, something along those lines. All right, let's turn the page. Here's the back side. So the fully inflated basketball has a radius of 12 centimeters. So here's a basketball. Awesome. And we have a radius of 12 centimeters. Your basketball is only inflated halfway. So we're halfway filled. How many more cubic centimeters of air does your ball need to be fully inflated? Express your answer in terms of pi, then estimate how many cubic centimeters by then using 3.14 to approximate pi. Okay, so a basketball is a sphere. The volume of a sphere is found by doing 4/3 pi r cubed. That's our volume of a sphere. So in our case, we keep the 4/3, we can keep the pi like a pi, and our radius is going to be 12 to the 3rd power. Okay, so that's going to be 12 times 12 times 12. Okay, got that. No problem. That's the 3rd power. So let's take a 3 here real quick. And I'm going to divide a 3 into one of these guys here. 3 goes into 12, and it leaves me with 4. So we can get rid of that, get rid of that. So I'm left with 12 times 12, which is 144, times 4 times 4 is 16. So 144 times 16 is going to be equal to 2,304 pi. All right? No problem. That sounds great. We got that right there. So that's the whole thing. But that's if it was completely filled. It's not completely filled, so now we're going to take that answer and we divide it in half because it's only halfway filled. So that's if it was completely filled, it'd be that. We're dividing it in half. So half of 2,304 is 1,152 pi in centimeters cubed. If then I want to approximate it with 3.14, then I need to multiply 1,152 times 3.14, and when I do that, I end up with 3,617.28 centimeters cubed. So in terms of pi, we have that, and multiply it out with 3.14 as an approximate, I have that. All right. Here we go. We're going to go and solve each of these here. Okay, I'm going to go first of all, for this one, I'm going to divide both sides by 2 first off. So I have 3 minus 2c equals 15. I'm going to subtract 3 from both sides. So negative 2c equals 12. Divide both sides by negative 2, and c equals negative 6. Over here, I'm going to go ahead and I'm going to add 6x, add 6x. So we have 9x over here equals add 2 equals 9 over there. Divide both sides by 9, and x equals 1. Over here, it's not quite as nice, right? It just isn't. I'm going to go ahead and distribute first of all. So I have 31 equals 5b minus 10. I'm going to add 10 to both sides. So I have 41 equals 5b. We'll divide both sides by 5. So 41 over 5 equals b. And that's just all there is to it. Not a nice answer, but it is the right answer. Okay, next up we're going to graph the line going through negative 6, 1. So negative 6, 1, let's put that in there. Negative 6 is here, 1, so there's a point. Negative 6, 1. Got that. And then it has a slope of negative 2/3. Negative 2/3 is our slope there. And we want to write the equation for the line that goes through that point with that slope. Alright, so if that's the slope we're on, we know that so far we have y equals negative 2/3 x. So we know that's what we have so far. And what we want to do to find out what is our b value is plus b. A couple ways I can go about solving this for b. I can plug in the numbers that I know into the x and y, and that'll tell me what b is. Or I could just use the graph and go down 2 over 3. Let's first of all plug things in real quick. Let's put 1 right here. This is our equation. Well, not yet. We're going to put 1 right there and make it equal to negative 2/3 times a negative 6 plus b. We're solving for b here. So let's do this here. So 3 goes into 6 2 times. Negative 2 times negative 2 is positive 4. So 1 equals negative 4 plus b. We're going to add 4 to both sides. So we end up with 5. So that's not quite right here. 5 equals b. 5 equals b. Oh, sorry. 2, 4. Oh, it's positive 4. Sorry, positive 4. Sorry about that. Be careful there. Don't do what I did. A negative times a negative is a positive, so we have positive 4. So now we're going to subtract 4 from both sides. So negative 3 equals b. So for my equation, I would say y equals negative 2/3 minus 3. That's my equation. Let's check that by using the slope way. Going down 2 over 3. So down 2 over 1, 2, 3. Got it. Down 2 over 1, 2, 3. And there's the point at which I cross the y-axis. And that happens here at negative 1, negative 2, negative 3. So that does match my y-intercept right there. Perfect. That's it for the day. Hope that helps you out, and we'll see you next time.